So we'll be talking about independent events and dependent events. Both of these events will be defined with respect to probability. What are independent events? Independent events refer to the occurrence of one event not affecting the probability of another event. For example, let's say we are rolling a die and flipping a coin. Both of these are two separate events. We can say that the first event is rolling a die and the second event is flipping a coin. Because the outcome of the first event does not affect the outcome of the second event, these events are said to be independent events. In other words, rolling a 6 doesn't increase or decrease the probability of a coin landing on heads or tails. The probability of getting heads is 0.5 and it stays that way regardless of what you roll. To calculate the probability of two independent events happening together, you can use this formula, where the probability of A and B is equal to the probability of event A times the probability of event B. Let's do an example. If you roll a 6-sided die and flip a coin, what is the probability of rolling a 5 and getting heads? The first thing we should do is write down the formula. But in order to use this formula, we need to know the probabilities of each event. If you watched the previous video, you should know that the probability of an event is equal to the total number of favorable outcomes divided by the total number of possible outcomes. For the first event, there is only one favored outcome, which is rolling a 5, and there are a total of 6 possible outcomes since we are rolling a 6-sided die. As a result, the probability of rolling a 5 is equal to 1 over 6. For the second event, we know that the probability of getting heads is equal to 1 over 2 or 50%. And we know this because there is only one desired outcome, which is getting heads, and there are a total of 2 possible outcomes since the coin can land on either heads or tails. Now that we have the probabilities for each event, we can use the formula. And all we have to do is multiply them together. 1 over 6 times 1 over 2 gives us an answer of 1 over 12. As a result, the probability of rolling a 5 and getting heads is equal to 1 over 12 or 0.0833. What are dependent events? Dependent events are simply the opposite of independent events. Dependent events refer to the occurrence of one event affecting the probability of another event. For example, suppose we have a box that contains 10 marbles. 7 of the marbles are green and 3 of the marbles are blue. Based on this, we know that the probability of drawing one green marble is 7 over 10 or 0.7, and the probability of drawing one blue marble is 3 over 10 or 0.3. If we randomly select 2 marbles from this box, what is the probability of drawing a green marble and then a blue marble without replacement? A common mistake in solving this problem is by using the formula and then multiplying the probabilities of each marble together. So you'll have 7 over 10 times 3 over 10. However, this process is incorrect. This formula can only be used for independent events, and we know that this is not an independent event since the marbles are being drawn without replacement. The term without replacement means we are drawing the marble without putting it back into the box. This means that the probability will change after every draw. As a result, this is a dependent event, where the probability of one event affects the probability of another event. In other words, drawing the first marble affects the probability of the next marble. Let's see why this is. For the first event, there are 10 marbles in the box, and since we have a total of 7 green marbles, the probability of drawing one green marble is 7 over 10 or 0.7. For the second event, the probability of drawing a blue marble is not 3 over 10. Since there is a total of 9 marbles left in the box, with a total of 3 blue marbles remaining, the probability of drawing a blue marble is now equal to 3 over 9 or 0.33. As you can see, the probability of drawing a blue marble has changed. At first, it had a value of 0.3, but now it has a value of 0.33 or 3 over 9. As a result, this is a dependent event because the occurrence of the first event affected the probability of the second event. Now to finish this problem, all we have to do is multiply these two values together. 7 over 10 times 3 over 9 gives us an answer of 7 over 30 or 0.233. Let's do another example using the same scenario. What is the probability of drawing 2 green marbles without replacement? Feel free to pause the video so you can try this question for yourself. To solve this question, we will use the formula, except we have to make some modifications to it. The probability of A and B is equal to the probability of A times the probability of B after event A has occurred. I will assign event A as drawing the first green marble, and I will assign event B as drawing the second green marble. The probability for drawing the first green marble is equal to 7 over 10, since the box is untouched. If this event was successful, there will be 6 green marbles remaining, with a total of 9 marbles left in the box. Therefore, the probability of drawing the second green marble is equal to 6 over 9. And finally, to get that answer, all we have to do is multiply these two values together. 7 over 10 times 6 over 9 gives us an answer of 7 over 15, or 0.4667. To quickly recap, for independent events, the outcome of one event does not affect the outcome of the other event. If events A and B are independent, the probability of A and B occurring is equal to the probability of A times the probability of B. And for dependent events, the outcome of one event does influence the outcome of the other event. This is commonly seen when drawn items are not returned. If events A and B are dependent, the probability of A and B occurring is equal to the probability of A times the probability of B after event A has occurred.